5G NR based on the new infrastructure supporting NMO, okay, random access network and equipment. If you see this, it's a pointer. So this is the mobility, high data rate, then the high, very high capacity, reliability and the resilience, security, very low latency, long battery life, massive number of devices we can use together simultaneously, and it's the flexible. There is a mobility. Okay. So these are the advantages of 5G communication. Why we should going for this high speed, enormous capacity, low latency, IoT compatibility, provide uniform, uninterrupted, and consistent connectivity, technology to gather all the network on the one platform, connectivity across the world, and much more. It provides the better for the many new applications. It is that much important. Next. So this figure basically a 5G. It gives what we are using in the earlier and what the 5G gives us. So earlier it is the rate, that is the data rate. It should be in the 10 megabits per second to 100 megabits per second. Okay. So it is earlier, now it goes to 100 10 times. Then earlier the spectrum efficiency is, if it is 1x, then it increased by 3 times, 3x. Then the mobility kilometer per hour, it is 350. For the INT 2020, it becomes 400. And then latency in millisecond, 10 millisecond, it is dropped down to 1 millisecond. Collection, that is the connection density, that is the traffic, that is for the devices per kilometer square. It is 10 to the power 5. It lies to 10 to the power, I think 6 or 8. It is 6, 8, sorry. And then the network efficiency, it is 1x, now it becomes now 100x. And these are the traffic connectivity, that is the channel capacity it is using. And here is the peak data rate, that is called the 1 GB per second to the 20 GB per second. These are the drastic changes we are getting from 4G to 5G. And if it is for the 6G, it further reduces. Okay, next. So these are the technology, that is the 5G, 6G technology requires the 5G wireless technology, that is the large coverage, extremely low latency, and extremely high data rate. And we may say the extremely high reliability is privacy, then extremely low energy and cost, because if you use the particular technology in the large scale, and then extremely massive connectivity. So more thousands of devices they can connect together, and these are the basic 6, we can say, objectives of IoT. Next. So this is the 6G communication, the connectivity, the physical technologies, artificial intelligence we are using, energy efficiencies, and the massive IoT support. So that is the connectivity, it is in terahertz communication, very high data rate, extremely low latency, and I would think physical full duplex mode we are using, advanced channel estimation, and intelligent surfaces. Okay, next. Okay, the same thing will be here in this figure also. So they are giving the 6G, we can say the expansion in the data rate, in the radio latency, the response time. It is 0.1 millisecond. Earlier it was 10 millisecond, then it becomes 1 millisecond. Now it is 0.1 millisecond in the case of 6G. So next, these are the advantages and disadvantages we are going to discuss next. So challenges are also there. Challenges basically the very expensive, very we can say, and therefore difficult to implement, and it requires a large infrastructure. And to get this in the India, it is not that much easy to get that, we can say, expensive technology to drop it in India. But of course, we are aiming for 2030. Hope so we can. Next. So this is in the bullet form, whatever we discussed, that figure indicates. Next. So, what are the different issues we have to face in the 6G challenges? Research is still going on. It's a very expensive, very high cost. Infrastructure is also expensive, and the large infrastructure is required because, as we know, the frequency increases, wavelength decreases, so it travels a less distance, and therefore we have to deploy a many number of antennas. Okay, and because of that numbers of antenna base stations, we have to, and that should be connected with the help of optical fiber, and therefore it becomes very expensive. And now security issues are there. We are saying it's very protective, but nowadays you can see the many multiple scams are going on. Okay, with the help of mobile phones. So that is the challenging things. Okay, they are not imaging before, but when any system have advantages, some people are going to use in adverse direction. There are the disadvantages also. People are utilizing that, and accordingly, this time. Next. So these are the applications where it is used. It is in the smart education, the smart city, the smart farming, then the smart gaming, that is virtual gaming, and then Internet of Things, very long battery life. Now you can see if you go to the market and purchase a four-wheeler, okay, earlier the battery life is only 1 year, 2 years. Now they are giving the lifetime, we can say the battery life. Lifetime is 15 years, because in vehicle if you purchase, it can be up to the 15 years if you can drive. After that you have to take the extension for that. But they are giving the 15 years battery life. Okay, so similarly things is also possible in case of mobile phones also. Next. So massive MIMO. Next. So massive MIMO, this wall itself, multiple input, multiple output, introducing the massive MIMO, wavelength and antenna size, simple dipole antenna. We are focusing on this cross polarized antenna, linear array antenna, and the MIMO, antenna separation and beam width, and beam forming and beam steering, that we have to cover in the coming few slides. Next. So if you see this, basically these are the panels. It has zoomed in. This is one panel, another panel, and back side third panel. It is with an angle of 120 degree. So it covers complete 360 degree, and therefore you can focus the beam wherever you require. So the element यहाँ पे लिखा है greater than 100 elements, but it may be a more than 1000, 1020. Okay, it's a massive MIMO. We have to use this. If you see this, these are the individual antennas. 1, 2, 3, 4, 5, 6. These are the antennas. Individual antennas are there. They are going to place in the matrix form, and we can train individual antenna as well as we can train a group of antennas. And accordingly, we can focus the beam in any desired direction. Next, see that you can get the things in the earlier 4G communication. So these are the base stations, okay. And if you see, the beam is radiating throughout the time 24/7, irrespective of that, whether the user is there or not. But it spreads, radiates the beam or energy continuously, and that is the wastage of power. That is the wastage of power. But if you see in the 5G communication or 6G communication, so what you are observing, so the beam can focus wherever is required. But it not only focuses horizontally or downward direction, it focuses in the upward direction also. If it is upward, we can say the vertical polarization. If it is along the line, it is called the horizontal polarization. So these are the things. And if you are sitting in a car, if you are talking on phone, so car is moving as well as your beam is also tracking you. That's why you are getting the continuous upward. Then rest of the things are there. Then it can be giving the charge, that is the charge to the next base station. All these things that you have learned already in the mobile communication. I'm not doing that. So what I want to say, beam is, if you see, these are the 24/7. The beam is radiating in the 4G communication. Okay. क्या बोला हमने? Irrespective of user, वहाँ पे किसी को आवश्यकता है नहीं है, nothing, but it radiates, and therefore large wastage of power. But these are the beam is focused only in this elevated elevation. Okay, so if you are in the any floor, you can get the signal, because the high-rise buildings are in the Bombay, not in that much in Nagpur. 100-story buildings are there. then you require, and if the mad person is standing on the ground, so both the person should get the signal, and this makes possible because of the 5G technology. Okay, and it not only it focuses the user, but also it tracks the user, and it can do the continuous connectivity, or there is a less possibility of drop of signal is there. Next, so the very high spectral efficiency, then increase the capacity, improved energy efficiency, superior beamforming and directivity, better reliability and coverage, and supporting high data rate, and the robustness against the interference, and the most important, improved user experience. Finally, their customers are, we all. So if you are satisfied, then that is the things. And of course, the narrow focus beams reduce the power wastage, and that also it uses the beam technology. Means it focuses the beam only when you start calling someone. You might have knowing the things. Once you press the buttons on your mobile for the particular user, then what happened? It converts your analog into the digital, then it goes to the base station. Base station, it receives the signal. Once the base station gets the signal, then it retransmit it to the nearby base station. Okay, if you are in the home, but base station is not in your home, base station nearby to your home, then that signal goes to base station first, which is closer distance to your home, and then mobile gets the signal. Okay, if you just want to talk to person sitting in USA, you can just dial, you can get the immediate response. So just imagine there is no delay, but you can get the you can talk within a few seconds, or not a second also. It is a in millisecond or microsecond. You next. So these are the 5G 6G technology having the, these are the steps we have to use it, and in coming slide we have to see next. So what happened? Basically earlier we are focusing only on this, that is electromagnetic spectrum. We get only the 3 kilohertz to the 6 gigahertz or 5 gigahertz. Giga means 10 to the power plus 9. Giga means 10 to the power plus 9. If it is minus 9, it should be nano. If it is plus 12, tera. Minus 12, pico. Plus 15, peta. Minus 15, femto. Plus 18 and minus 18. Search yourself, you will get. And then the spectrum finish. That is more than enough. So you are 21, no, 18, it is 18. So there is a low band, less than 1 gigahertz, more coverage. Speed is 100 to 300 megabits per second. Mid band, 1 gigahertz to 10 gigahertz, less coverage, and speed is 400 to 700. And then high band. These are the 3 bands techniques we are using in the 6G communication. Earlier, most of the frequency spectrum appliances use only this one. For these 6 and above is totally empty. It is totally empty. No one utilizes it. But we are utilizing it. Okay, and therefore it has been get more expansion, and we are utilizing the numbers of applications in the area about 600 gigahertz now. So see the spectrum, and therefore there is a more crowd, there is a more delay, because everyone wants to accommodate their appliances only in that up to the gigahertz. Okay, but now the upper 6 gigahertz, that is totally empty, and now here we try to use that particular spectrum, and therefore there is a less traffic, means low latency. Okay, one day that will also get overcrowded, and we feel okay, this is not giving the proper response, so we have to go further. And that is the technology, and that is the research. Next. So these are the things. Okay. So the LMO satellite, and then we can make the signals to this. Next. So just we start with the very simple things. So how to calculate the wavelength and the antenna size. Okay, because I know that you are not all the experts of antenna. And if you are talking about the blah 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 blah, बोल क्या हो गया, समझ नहीं आया क्या पढ़ा है. But here I focus is for the general public also. They should also get excitement. Yes, we are getting something new in this range. Then the fifth now, for example, we have to calculate this. Let us say it is a 700 megahertz, 1800 megahertz, 3.5 gigahertz, 28 gigahertz, and 40 gigahertz. If I ask calculate the wavelength, you can use the calculator. Calculate it, someone calculate it. How much anyone have a calculator? मोबाइल फोन में कैलकुलेट होता है वैसा. ओके ओके बट आई एम नॉट टेकिंग दैट टाइम बिकॉज टाइम पास नहीं करना आपको, लेकिन करते आना चाहिए. देन आई विल शेयर माय Dhares's thumb rule, then you can do the answer within a second. Okay, that is the thing. Okay, let us take if these are the things to be calculated. Now what is Dhares's thumb rule? My thumb rule is not my thumb rule is because of, let us take, whenever you can assume that this is the frequency. If you take this is the frequency of one let us take the frequency is in gigahertz. Okay, and then the wavelength it is in centimeters. And if you say the frequency it is in megahertz, then your wavelength it is in meter. So what Dhares's thumb rule is there. If someone says 5 gigahertz is the frequency, what is the wavelength? Then there is a big question. First of all, we know that she is equal to f by lambda because we are all meters. Then question will come, then what is the velocity of light? That also we know 3 to the power 8 meters per second or 10 to the power 10 centimeters. Then we require to calculate. After that, okay. But if you remember the thumb rule, that is whenever it is in gigahertz, wavelength it is in centimeter, and you remember only the figure 30, and you remember only the figure 300. So if someone says the frequency is 5 gigahertz, 30 by 5, your answer is 6 centimeters. You can calculate within a second. If someone says the wavelength is 6 centimeters, how much is the corresponding wavelength? Frequency. Take 630 by 6, so 5 gigahertz is the frequency. This is about the, you can say, if someone says 10 gigahertz is the frequency, how much is the wavelength? Your answer is 3 centimeter is the wavelength. And now, but when it comes to the megahertz frequency, if someone is 100 megahertz is the frequency, how much is the corresponding wavelength? Remember, it is in meter. So 300 by 100, 3 meter is the answer. Corresponding wavelength. Okay? If someone says, let us take 10 meter is the wavelength, how much corresponding frequency? It is in meter, this answer is in the, we can say, the megahertz. So 300 by 10, so if, how much it is? If it is 300 by 10, so one will get cancelled, nothing but 30. 30 megahertz is the frequency. That is the way you calculate. And why it is called thumb rule? Because it is not possible, or we can say visible, for kilohertz. You might be there, so take a 1000 for kilohertz frequency, but it will not be, unfortunately. Otherwise, it may get patented. Okay, so it's a simple logic is there, nothing else. So we can find out the frequency within a second with the help of this thumb rule, and that's why I'm saying it's Dhares's thumb rule. ऐसा कुछ नहीं है, वो सिर्फ लॉजिक ही है. Okay, but अगर तुम बोलेंगे भाई frequency is 15 kilohertz, how much is the wavelength? In that तुम बोलोगे 3000 will be the next factor, 3000 by 15, how many things? It will not be the correct answer, and that's why this kind of thumb rule for this. So if you want to go for this, for example, let's. So let us say the 700 के लिए क्या frequency है? That is the wavelength is 42.85 centimeter if you calculate. If it is 1800 megahertz, answer is 16.6 centimeter. For 3.5 gigahertz, it is 8.6. For 28 gigahertz, 1.07 centimeter, and for 40 gigahertz, it is 7.5 mm. So we start with the centimeter, goes up to the mm wavelength for the 40 gigahertz. And the length of height of the antenna or length of the antenna size is half the wavelength, lambda by 2. And if you just divide it, if it is 42.85 divided by 2, means antenna size is around क्या हो जाएगा 21 point something 442 or this. Such a big size antenna, not possible to use. If your mobile phone having tried to use this size, it is not possible. Okay. So if it is 1800, so then it becomes a 16.6 centimeter. all these things. So half of the thing, but if it is in optic gigahertz, 7.5 mm. So 7.5 mm divided by 2, 3.5 mm. That is the size of the antenna. Just imagine 3.5 mm. You can accommodate many antennas together. If you have a panel, let us say आपको 1 मीटर या 1 मीटर बाय 2 मीटर का पैनल दिया है, उसमें आपको एंटीना को असेंबल करना है. तो व्हाट यू नीड, अगर पहला वाला है तो उसमें कम नंबर ऑफ एंटीना आएंगे, दूसरा वाला है थोड़े से ज्यादा आएंगे, तीसरे में और जैसे जैसे वेवलेंथ घटती जाएगी, मोर एंड मोर एंटीनास टू बी अकोमोडेटेड इन दैट पर्टिकुलर साइज ऑफ अ पैनल. ठीक है, एंड मोर नंबर ऑफ एंटीनास मींस मोर नंबर ऑफ डायरेक्टिविटी. दैट विल बिकम द पॉइंट आपको. नेक्स्ट. So let us assume the simple dipole antenna. Dipole antenna बोलने के बाद what it is comes in your mind? This is the dipole antenna. There is one wire. This is another one. This is called the dipole antenna. And if you are applying signal to this positive, negative, of course negative, positive AC signal applied, then you can get it goes here. Then continuing, if you just draw this way, okay, I will draw one line and then another one. It is like this. So if I ask the question to you all, which one will radiate and which one is not going to radiate? Which antenna is radiating? This is figure A and this is figure B. अगर मैंने पूछा, ठीक है, आंसर might be wrong, right? इसे छोड़ दो, है ना? अगर मैंने दो में से कौन सा एंटीना रेडिएट करेगा, व्हाट इज योर आंसर? Which antenna will radiate and which antenna will not radiate, or which will act as an antenna and which is not going to act as an antenna. So this will not be going to radiate. This is correct. Only the direction of current. Path is not, loop is, there should be a closed loop. Current, when the current will flow, if the loop is complete. Here the loop is not going to be complete. Here the loop is going to be complete. It starts radiating and goes like this, then goes like this. This is the way it will start radiating. That time, this is positive, this is negative. In the next half cycle, this becomes negative, this becomes positive, and now the lines, जो ये पहले तीन लाइन है, it has been shifted further, and the new lines will be developed. But whose direction is opposite to that earlier one. Means इसके बाद में जो होगा वो कैसा दिखेगा? It should be like this. So it will radiate. These lines goes further. Okay, it goes further in this direction and form the loop. Then this is the other line and goes here and form the loop. Higher potential to lower potential. Okay, हम तीन बनेंगे इसके. Okay, so this is the way, and the new lines to be developed. That time this is negative, this is positive, and then new lines to be developed in this fashion, and whose arrows are this. So ये distance के बाद में ये आगे जाएगा and all this. Then another cycle will come. Then first will be detached. Another cycle will come. That first will be detached. Okay, we will come to that point little later. Next slide. See, this is the dipole. So what is your drawn? It is the dipole. This is the way. So this is the AC current we are applying. This is the lambda by 4. Lambda by 4. This total becomes a lambda by 2. Size of the antenna to be a lambda by 2. In that situation, you can get now next. See, if this is the frequency 3.5 gigahertz, lambda is equal to C by F. If you calculate, it is 8.6. I mean, 8 करना पड़ेगा. But if you know the thumb rule, you can use this and try to find out the answer. It will be early. Next. Then what is this is the way. Then here is the electric field line. That time this is positive, this is negative, higher potential to lower potential, and this is the magnetic field. And that's why E and F, electromagnetic field, will be generated. What is an antenna? Antenna is simple a transducer which convert a one form of energy into another. Means when it is used as a transmitting antenna, it converts your electrical energy into the electromagnetic waves. Whereas when it is used as a receiving antenna, it converts your electromagnetic waves into the electrical waves. There are two sets of antennas. transmitting, which transmits the signal, it converts electrical into the electromechanical, and receiving, it converts opposite of that, means electromagnetic energy into the electrical signal. And that is the two sets of antennas that we have used it here. Okay, so see, this is the, let us say this is positive, this is the positive negative. Okay, this is the voltage. Voltage is maximum at the center. Okay, corresponding current is minimum. Then when voltage is maximum negative, then corresponding current is positive. See, this is the way the things. Antenna radial curve is what exactly? So impedance, whole things depends upon the impedance. And this, let us take the antenna. This is the way. This is the way it radiates the signal. Let us say this is the way it radiates the signal as we are seeing. And path कैसे complete हो गया? Sorry, this path कैसे complete हुआ? This is the way अभी अपन direction ये किया है. Let us say these are the direction. This is positive, this is negative. Perfect. And so loop कैसा हो गया? ये गया, ये गया. This is the way loop has to be complete. And this. That's why the direction of current is like this. This is very basic. हमें यही पता नहीं हम हमारे बुलाता पढ़ा रहे उसको कोई मतलब नहीं है. So we should get some addition while learning to listen this particular session. Next, okay. So see, these are the way how it radiates. So I have taken this beautiful image from the Wikipedia. Okay, I have given the source also. You can see the source. You can get these things from the Wikipedia. So what is your observation? Your observation is this is the, let us say this is the electromagnetic waves. Okay, this is, or we can say electrical signal is applied. Corresponding direction, this is the voltage will be developed, positive, negative, then it's continuous going on, just like this, you apply the electrical signal. Okay, and accordingly you can get the voltage. When the voltage is maximum, current is minimum, voltage is vice versa. And we know that Z is equal to V by I. Z is V by I. When voltage is maximum, current is minimum. Okay, so we have to find out accordingly where to be. Next. See, the things which I just explained on the board that you can easily observe with this animation. What this animation indicates? This is the transmission line or waveguide structure or transmission line. This is the input source. These are the standing waves which arrow operate with which are the field because of cycles are alternating. AC cycle is. If you see, these are the things. Okay, and once it receives from this, once it releases, it uses the path to be complete, and this is EM wave to be detached from an antenna, and this is the dipole antenna. So you will get the antennas to be detached, and this will be act as a transition layer or transition medium where antenna क्या है transition medium, it converts electrical signal आए electromagnetic signal को दे दिया. That is the difference you can see here. Okay, next. All right. Next. Now we come to the power density. This is also very important word in case of antenna. So power density, if you see, this is an antenna, okay, and this is the antenna. How that wave is to be radiated? It is start with this, it goes here, comes back. Means it is maximum at the center and minimum along the axis, or we can say along the antenna axis. Voltage is maximum कहाँ रहेगा? Perpendicular to this, minimum to be here. Okay, next. See, you can get these things very easily. The maximum radiated power density is at perpendicular to the center of a dipole, and it is minimum in the direction of a pole. कोई ना यहाँ तक कुछ पूछना है किसी को? नींद आ रही है? Because of heavy snacks in the morning. Okay. Make it easy. So what I am saying, if this is antenna, you will get maximum radiation. अगर radiation देखना है, तो हमें perpendicular direction में you can get the maximum radiation and minimum to the antenna. So it is अगर ये करना है radiation, it can be maximum at the perpendicular and minimum towards zero here and max here. That is the way the power has to be distributed along the antenna if the antenna length is we can say lambda by 2, half of the level. Means lambda by 4 upper, lambda by 4, this one is lambda by 4, this one is lambda by. Next. See, so this is the way, these are the way it radiates. Okay, so the maximum power transfer, if this is the transmitting antenna and this is the receiving antenna, okay, this is the receiving antenna, if both are placed in parallel, that the coplanar, then it radiates the maximum, whatever the energy it radiates, it will be given to this antenna. But if I do this, it is not possible. Minimum might be low or may not be low any energy. Okay, so that is the way. So you can get the maximum power is transferred when the transmission and receiving and dipole antenna are in parallel. Means a coplanar. That time it delivers the maximum energy transfer parallel. Next. So the cross, we have to think about what is meant by the cross polarized. If this is an antenna, this is transmitting antenna, this is receiving antenna. If it is parallel, if I change it, it is cross. But in this situation, it will not receive much signal because it transmits in perpendicular और इसका कैसा है horizontal. एक है तुम्हारा, ठीक है? This is the way it transmits. It will not use. But that is nothing but the cross polarization. And if we use the cross polarization, and this is the cross polarization, we have to use the 5G technology. And how it is useful in the 5G technology, we have to focus like that. So next. So this is the horizontal. If this is the electric field, then this is E field is horizontal. It is called the horizontal polarization. If the E field is vertical, it is called the vertical polarization. This is the direction of E field. Next. See, this is the vertical beamforming, and this is called the horizontal beamforming. This is the, we can say, azimuth plane, and this is the elevated plane. Vertical means elevated, elevation, and horizontal means azimuth plane. There are two types of the plane in the antenna radiation. This is called the horizontal beamforming. This is called the vertical beamforming. Next. See, this is the electric field is vertical, so it's a vertical. Electric field is this is magnetic. Blue is the magnetic field, red is the electric field. Horizontal, यहाँ पे horizontal electric field हो गया. This is the horizontal polarization. फिर उसमें clockwise और anti-clockwise में होता है, circular polarization में होता है. Next. So this is how we got out. This is called the this, if it is move along the line, it is called the horizontal polarization. And if you see here, you can get the this is called the horizontal polarization. Are you getting this? Electric field है, it is in horizontal direction. This is called a linear polarization. What about the circular or electrical? Is next take up. This is called the circular, where Ex and Ey field is common. Red is the resultant. That is fixed. And if it is electrical, that Ex is not equal to Ey. Okay? So this is given here. Okay? So this is Ex is not equal to Ey. You will get the electrical polarization. And when Ex is equal to Ey, if it is a clockwise, then it should be a positive. If it is anti-clockwise, it should be negative. But little bit negative because there is no use. Next. See, accordingly, what will happen? Polarization multiplexing. This is the antenna is vertical. This is the antenna is parallel to it. It gives the maximum radiation. And this is the antenna is horizontal. This receiving antenna is also horizontal. दोनों को मैंने ऐसा रख दिया. It also delivers the maximum power. दोनों को ऐसा रखा parallel में. It also delivers the maximum energy. Okay? So उससे क्या होगा? Same frequency can be used in both transmitters and the transmitter with horizontal and vertical polarization. दोनों में frequency same है. But एक कर रहा है horizontal polarization, एक कर रहा है vertical. So this is for vertical, this is for horizontal. Next. So how to connect these two antennas? So we have to connect like this. This is the way it goes here. Other tape will come down here, and now this is the way it goes here. Accordingly, it gives the one antenna structure. This antenna structure. Let us take horizontal. This antenna structure. Let us take vertical. It may be a vice versa. Accordingly, you can get the cross polarization signal from the same antenna, which is placed in cross. This is for horizontal and this is for vertical. This is. Okay, next. So linear array antenna and beam. Next. So these are the different arrays. Why we want to use the array and all of this. Okay. So what it exactly happened? So this is called the cross polarization. So if you look carefully, this is the way it gives. This is one, another, second, third, fourth, fifth, sixth, seventh. These are the things. Panel. I have to use 1, 2, 3, 4, 5, 6. It depends whether it is 220, 250, 2R, whether it is 44R, it is 30, 60, 40, 64R. Means 64 transmitting, 64 receiving antenna. Accordingly, you will get. A can allow 88R is massive MIMO. Today we are using 128 by 120. Okay. So these are the concept of 2 by 2 MIMO. So these are the 2 by 2 MIMO. Okay. Then next. So what we can get? इसमें क्या करना पड़ता है? So if you use this one line, apply one signal to the particular this type of inclined antenna, downward antenna, common signal you apply, okay, and another signal you apply from this will be applied to the another set of antenna. But this one, these are the things, okay. We are applying one set to this antenna, another common frequency source to this antenna. Then what is your radiation? You can observe at 0 degree you will get the maximum radiation. At 0 degree you will get the maximum radiation, and these are the sign waves. Okay, this is the way it gives the radiation from the cross polarized antenna. Okay, next. Means अभी ये horizontal दिख रहा है. Similar way you get the another way. Means when there is a vertical, there is a vertical one side. If it is, this is the way you will get maximum, and another way that is called the vertical way you will get the maximum. Two types of the beam unit. Next. So in the sector array, in the earlier 2 by 2 MIMO, third generation of partnership project, that is, इसको बोलते हैं 3GPP, third generation partnership project, 3GPP. Okay, in 3GPP, so you will get the 2 by 2 MIMO and optional feature. See, 1, 2, 3, 4, 5, 6, 7. हर एक इसमें दो एंटीना है, एक हॉरिजॉन्टल पोलराइज, एक वर्टिकल. Similarly, here also. These are with the 120 degree angle. As I told you earlier, it covers the whole, we can say, universe. This is 120 degree angle. Here is 120 degree angle. This is one way, total becomes 360. It covers all the 360 degree angle. So this is called the 3GPP technology, third generation. Then the fourth generation. Go further. In fourth generation, you are getting the two sets in every panel. एक horizontal, फिर दूसरा. ये दो सेट एक पैनल में, दूसरे ऐसा दो क्या सेट you are getting in the each individual panel. Means अभी आपका क्या हो गया उसमें, इसको क्या बोलेंगे हम? फर्दर एक बार पीछे. ऐसा पीछे. In 5G, these are the matrix. Okay. अभी they depend करता है. If it is 88R, then it is a massive MIMO, and if it is more than 88R, all that system is called to be a massive MIMO. Okay. So these are the panels. Has to be placed with the degree of 120. Now, if you go to the while going back to the home, you can see on the tall buildings there are the antennas. I'm just giving the challenge. Ask yourself tomorrow, because I am not available tomorrow. Yeah, today you can tell me what is the name of that antenna. है ना, उसमें एंगल खड़े रहते ना. तो देखिए टावर पे, बेस स्टेशन पे, या फिर टॉल बिल्डिंग्स पे, उसमें दो टाइप के एंटीना दिखेंगे आपको. एक तो दिखेंगे आपको इस तरीके से, ओके, और दूसरा दिखेगा राउंड शेप. सिर्फ कोशिश करना इनके नाम क्या है. गूगल है आपके पास, गूगल पे सर्च करना क्या है, व्हाट इज द नेम ऑफ दिस एंटीना, व्हिच इज perfect sectoral antenna. Okay, that is the sectoral antenna. ये ऐसा नहीं है, ये इस तरीके से ट्रायंगुलर है। जस्ट इमेजिन अ पिरामिड, ट्रायंगुलर पिरामिड, एक साइड, दूसरी साइड और तीसरी साइड। अभी आप बोलोगे सर 4 क्यों नहीं रहती? फाइंड आउट द आंसर फॉर द गूगल। Why it should have 4 faces? Why it should always have 3 faces? Because of with the 3 faces अगर हमारा काम हो रहा है 360 डिग्री का, तो why we should simple. There is nothing much more. Okay. So we use the circular antenna in the form. Next, antenna separation and beam. Next, see, this is the antenna separation. What role? मैंने वो स्लाइड छोड़ दी थी, आप थोड़ा पीछे लाइए, एरे एंटीना थोड़ा पीछे लाइए, मैंने छोड़ दिया था क्योंकि आपको पता होगा। और चलिए, हाँ बस देखो, एंटीना एरे को मैंने छोड़ दिया था, ऐसा आलू क्या कवर है आपको पता है सब, तो लेकिन हो सकते कुछ न्यू कवर हो। सो ज्योमेट्रिक व्हाट इट डिपेंड्स द 5 एलिमेंट, geometrical layout of antenna element, spacing between the antenna element is very crucial, excitation amplitude, phase of the individual element and phase field pattern of the individual element, ये सब के ऊपर डिपेंड करता है एरे एंटीना का रेडिएशन पैटर्न। रेडिएशन पैटर्न ऑफ एरे एंटीना, इट इज द सम ऑफ ऑल दिस, and geometrical layout of array element, spacing between the element is playing very important role that we will discuss now. Excitation amplitude, whether it is in phase है, out of phase है, 90 degree out of phase है, phase is also playing a very crucial role to focusing and clearing the beam and all. Next, अभी उधर चलेगा, तो आगे आगे हाँ ठीक। Now if you say this is the point 1 lambda, it is spacing between these two. Antenna 1, this is dipole antenna, this is another dipole antenna. Difference between two is 0.1 lambda. Means they are placing very close to each other. बहुत नजदीक है, तो कोई मतलब नहीं आने का। It has no meaning. We have to place the arrow. Distance is sufficient. What should be the distance? That we will come to that point. So if it is so, then there is a continuous radiation पूरा का पूरा ये, ठीक? Means मेरे हाथ में अगर बल्ब है, इस individual element, if I blow that bulb, it radiates in all the directions. Same. तो उसका radiation pattern कैसा बनेगा? Like this. It is radiated in all the directions equally. ठीक है? That is the radiation pattern we will get with this. There is this array करने के बाद भी there is no use. This is constant. Okay? 0 to 60 degree, it is same. Okay? So radiation is practically independent of theta. Okay? Next, if you just take the next distance is 0.5 lambda. Distance between the two antenna is 0.5 lambda. In that situation, this is dipole 1, dipole 2. This is the angle theta. Okay? So direct separation is 0.5 lambda. So you will get this type of radiation. It is maximum at the 0 degree and minimum at plus minus 75 degree. This is the type of radiation pattern you will get, and this is the direction of donut shape. So maximum gain is in the direction, so that is called a donut shape antenna, or which radiates maximum to the perpendicular direction. Okay, so that is the way of transmission radiation pattern you will get. Okay, and that is the best radiation pattern. If you increase further, then side lobes start gaining. Next, if you increase the distance, if it is the lambda between the two dipole elements, then you will not get the one main lobe, but there are two secondary lobes, and radiation pattern will be like this. This is the main lobe, and this is the secondary lobe you will get. To get the secondary lobe is not designed. That can be known as side lobes. Okay, next. Then if you go for the 1.5 lambda, then this becomes further narrower. Okay, so and you will get the two sub beams, and accordingly you will get this is the main lobe, these are the another lobe, side lobe, this is another side lobe you are getting this. Means अभी क्या है, पावर आपका scattered होते जा रहा है, तो gain should be go on decreasing if there is a more number of lobes. Means it's a wastage. Power goes into the lobe, it should be a minimum lobe, or there should be no side lobe and no back lobe. But such ideal antenna we can never fabricate or never design. There must be a sum, but इसमें से हमें यही देखना है कि जितना कम से कम साइड लोब में पावर जाए, that is the motive. Okay, next. Then antenna beam forming. Next. So what is beam forming? The first question will arise. that is, it is a process of sending electromagnetic waves or signals in a particular direction rather than spreading in all directions. Means we have to make a direct to antenna. It should direct in a particular direction. Then why the beam forming is required? Efficient use power, use of spectrum, maximum data transfer, SNR to be increases, this noise to be minimum, because SNR means signal to noise ratio. Then good connectivity also. How are the beams created? Three types of technique: analog beam forming, digital beam forming, and hybrid beam. Next. See, if you just take a single element, it radiates like this. Globe. It is simple. It's an isotropic type of antenna. It radiates equally in all the directions. That is single beam. That is input, single radiating element. But if you want to make a direct to antenna, you have to use the two elements which has to be excited by the signal source. So then the power to be increased by, that is the 3 dB. Means double the gain you will get in case of this 2 dB. And if you go for the 4 element, the total power is to be increased by the 4x. यहाँ पे 1x, 2x, 2 element, 2x, 4 element, 4x energy in the forward direction is gain increased by 6 dB, 3 dB here plus additional 6 dB here. Total becomes 6. Total becomes 6. So 4 times energy is to be increased. Next. So the number of elements and the beam forming. Let us say here is the 2 element. You are getting this maximum at 0. Then if it is take the 4 element, what will happen? Gain will be increased. So gain will be here. यहाँ तक के gain ना, it has been increased. Why? Because the number of elements increase. If it is an 8 element, then gain will further increase. Now then there is a further, if you go on increasing the number of elements 16, 24, 32, gain will be go further and further. जितने ज़्यादा एंटीना यूज करोगे उतना ज़्यादा उसका गेन बढ़ेगा. सिंपल लॉजिक विल बी. नेक्स्ट. So the antenna beamforming have some disadvantages. So antenna beam is to be focused in a particular direction, that is the direct to antenna. So gain will increase. अगर हमने 4 बनाया तो 4 times तो gain बढ़ गया. But it focuses only in a certain direction. If user is here, user of benefits, they will get good coverage, long distance beam can travel, distance इन दोनों के बीच में बहुत ज़्यादा भी होगा get can. But if there's another user not reached by the beam, will be another user is there, but the beam is not going to focus in that direction. So the problem with making the more directive signal is you only benefit the right in front of the user, but if the user is different locations, then user not getting signal due to the narrow and the more directive beam, then steering the beam is also used as a phase direction system. So these are the ways. So one user will get the signal, another user will not get the signal. That is the drawback of beam forming in a particular direction. But to solve this problem, there are multiple solutions. I have given 2 solutions. Next. So then first solution what I get? I use this, but I am not excited with the common source. Common source means अभी तक देखा होगा सबके साथ में एक ही source लगा. But here I am giving individual, and in place of forming the one big beam of 4 types of gain, increased gain, I use the 2 sub beams, whose gain is half of earlier one, because power अभी divide हो गया. जो कमाई था ये अगर 4 times था, अभी मैं 2 कर दिए, तो ये 2 times. But advantage is both the users will get the signal. That is one solution. So excite the beam array with the different amplitude and phase. You can steer the beam, or you can focus the beam in a certain direction, but with the payoff price reducing the gain. Okay. Next. Now the multiple beam system. Now एक beam था यहाँ पे मैंने 2 beam बनाए, यहाँ पे weaker 4 beams. That also can be done. ठीक. Strong 1 beam, little bit less stronger 2 beams, and weaker 4 beams. But सिग्नल सबके पास पहुंचेगा. डिस्टेंस वाइज बड़ा ये डिस्टेंस गेन कम है यहाँ पे, लेकिन people will user you will get the signal from the antenna. Next, that is another solution. Then let us assume that this is another difficulty. Okay, so if user is here and there is a shadow zone, how to get the signal to this? Not possible. If I focus the beam, not possible. So I cannot focus the beam here at any cost. In that situation, I have to use the two reflectors. Beam will be going here, reflect back to this. Beam will be might be going here, reflect back to this. These are the way you can reach. There are two beams. One goes here. So एक beam की जगह पे मैंने दो beam बनाए. I form the two beam. One beam is focuses on this reflector. Another beam is focuses on this reflector. And now this reflected wave to be going here to the user. This is another solution you can get. So the दो beam बनाए and those go here. This next. So ये करने की जगह it is another way. We may say this is the common source. You can get the beam in there. This is another way, and this is for the phase shifter. इसको क्या बोलते हैं? This is the arrow. This one. This is the phase shifter. It introduces a phase, and once they introduce a phase in the beam, they can tilt the beam in any direction. In direction, and this is to be to get this thing, we have to use the algorithms, DSP processor. Smart antenna अकेला smart नहीं बनता, which complete his team, it's a team make the beam smart or massive. So this is the same signal. They are different in excitation, and now if you use here also the phase changer, or we can say phase shifter, it will steer the beam in that. Next, see for example, beam steering with a linear array, 8 element array. If this is the 8 element array, linear array number of antennas is equal to 8. Distance between the consecutive elements is lambda by 2. It will get here. Okay. Then you change the phase. It has been shifted to the 30 degree. Beam is maximum at 30 degree. Here, beam is maximum at 0 degree. Beam is maximum at 30 degree. And here is beam is maximum at I think this is at 15 degree. Okay. This becomes now 30 degree. This is the way you can shift the phase. By changing the phase, you can shift the beam accordingly. Selecting the delay, we steer the main lobe any desired direction. Next, smart antenna system management. So earlier way, these are called the unidirectional antenna. This is called the sectoral antenna. Okay. So it radiates equally in all the direction. There are antennas, and it will get the 120 degree. It will radiate like this. Okay. Sectoral is the solution of this unidirectional. Next. So for example, if you are here and the two people is you are getting the signal from two areas. One is noise, one is desire. और एक को तो आप सुनना चाहते हो, दूसरे को आप अवॉइड करना चाहते हो. You cannot. Your ear cannot give response to them. अगर दोनों आप ये भी बात करें मेरे से, तो मैं दोनों का हाथ सुनाई देगा. मेरे को इसकी बात सुनना है, इनकी बात नहीं सुनना है, फिर मुझे दोनों को सुनना पड़ेगा. And that is the noise. Okay, and that is the noise. So our human the ears cannot give the solution for that. So we have to use complete DSP processor. This is the direction of arrival angle 1. This is the another direction arrival angle 2. So I have to focus the null to this point. तो मैं इनकी तरफ null focus करूँगा, इनकी तरफ मैं beam focus करूँगा. So that is the beauty of DSP. It not only focuses the beam in the desired direction, but it also focuses the null in the undesired direction, and that is the beauty of things. So, but how it is possible? Not with the common human eyes, human ears, but it is possible because of the DSP processor. These are the weights, phase shifters are there. There is the algorithm. This is the direction of arrival 1, direction of arrival 2. Arrival 2 मुझे काम करनी है, तो मैं focus करूँगा null उस direction में और फिर करूँगा focus user पे. Next. So there are the smart system, switch beam system, adaptive array system. Switch beam में दो types है, single beam direction antenna, multi beam direction antenna, and the adaptive array antenna, that is single user beam forming and multi user. So maximum amount, this smart antenna is nothing but adaptive array system, not this. Switch beam. Next. So जैसा बोला मैंने किया है, इस तरीके से फिक्स कैपेसिटी, ओके, दिस इज द 120 डिग्री एंगल। सो यहाँ पे जैसा 100 यूजर है, फॉर एग्जाम्पल कंजेशन क्या होता है, ट्रैफिक क्या होती है, 100 यूजर उस डायरेक्शन में है तो मुझे 100 यूजर को सिग्नल जाएगा, लेकिन 101 आ गया तो 102 आ गया तो दे विल नॉट गेट द सिग्नल जब तक पहले कंप्लीट नहीं हो। आज वो सिचुएशन नहीं है, पहले थी, अभी नहीं है। So 100 is the capacity, or this is 120. Let us say 120 degree is the angle, 120 capacity. Here is 120 degree angle, 120 capacity. Here is 120 degree angle, 120 capacity. But 121 first, 121 square को नहीं मिलेगा, and this is the way. Okay? तो single beam में क्या होता है? It focuses one beam, and this is the predefined. This is the predefined. It's a multi beam. एक साथ दो को फोकस किया है, और next. See, these are the way. Switch beam low. Okay. So this is the way. Signal to this and interference to this. If it is dynamically phase array, then it focuses the null to the interference and beam to this. And if it is adaptive array, it focuses the beam here and another try to find out another path to get the signal to this. Next. This is called the traditional 4G system for understanding point of view. Next, this is called the massive MIMO, layer to ऊपर layer. Okay? इसमें भी multi-layer antenna. जैसे two block polar है, एक को vertical कर दिया, दूसरे को horizontal कर दिया. Let us assume this is 2 layer. You can add more layers in it. You can add 15 layers. We are adding 8 layers in the practice. Next, then the antenna beam steering and null steering. Next. Next, so when we focuses on the beam forming versus spatial multiplexing, beam creation and steering, massive MIMO and MIMO. Next, so the spatial multiplexing and beam forming versus beam forming. Beam forming generally used for the we can say the below the massive MIMO or MIMO but less than 88. So we focus on this and spatial multiplexing for the massive MIMO. So these are not the mutually exclusive, but sub 6 GHz versus millimeter. हम पेपर लिखते हैं एंटीना implementation for the sub 6 लिखने में क्या लगता है? But what is the meaning of sub 6 GHz? That is important. And what is the meaning of mmWave? That is both are in millimeter, but there is a difference. Next, what is that? If अगर MIMO की बात करूँगा, it is L/8. I'm order and above, and millimeter is 2/2. No, below 8. It is MIMO system, but mmWave. Then main technique, spatial, that is spatial multiplexing techniques we use here. This is beam forming to a single device. Then this is a single user. This is multiple user. Simple. Okay. Then channel characteristics reach multi-path, ideal for the spatial multiplexing, pure multipath due to the beam. Okay. Next. See, this is the single antenna which radiates equally in all the directions 360 degree. This is the radiation pattern. If you use the multiple antenna element, if you use one area, you have to go लगाया, तो gain will increase. Okay, you can get with this diagram. Next, see, this is individual, this is two antenna. क्या होता है इसमें? These two antennas radiate their individual signals, and they have to be a constructive in nature. So that destructive nature cancel with each other. We are only focusing on the constructive radiation pattern, and if it is a constructive radiation pattern, then the main beam low in the direction. So there are two signals. One is from this antenna, another ray is from another antenna. So let's see the corresponding adding more element. 3 element है, so you are start getting the side lobes. 4 element है, gain यहाँ पे जो कम था, now it has been increased. Gain बढ़ता कब है? जब आपका beam width कम होता है. Means just like वो ककड़ी होगा ना, ककड़ी वाला बलून, इसको इधर से twist करो उधर पहुंचे. Same type of things here. So what I want to say कि जैसा कि ये बीम है, it has a large bandwidth, coverage भी ज़्यादा है, but distance wise बहुत कम. If you go for this, if you are narrowing the beam, narrow किया उसको, तो इसकी beam width कम होगी, लेकिन gain बढ़ गया. फिर से मैंने इसको narrow किया, तो फिर से बीमविड्थ कम हो गई और गेन बढ़ गया. This gain बढ़ना means what? They are traveling the large distance. They are traveling the large distance. They are traveling a large distance. Okay, next. See, then adding the phase change, if you change the phase, it can steer the wheel. We have seen. Next. Now, the nerve steering, so we have not only focused the beam in the desired user, but also focus the nerve in the undesired. Noise. Next. So these are the things. Now we have seen the solution 2 जो था उसका वो था phase को add करो with changing the same 4 different input signals there. We could change the different excitation by the different phase. Same signal with different phases and amplitudes. You can steer the beam in the direction. Next. So these are the two antennas, main beam, these are the side lobes, 4 different input, then you can get the beam direction. Now, these are another way, we can get the 2 beams with lower gain. These are the way, you can get the signal to both users. Okay, next. So, this is the phase array. So these are all the phase, we can change the phase by means of changing its weight. So, technical word क्या है? Weight को change करते हैं, phase को change करते हैं. Nothing but this. And hybrid beamforming is equal to phase array or the multiple beam. Phase array for the multiple beam. Next. These are the way. User 1, beam is steering in this direction. Next. So this is the beam steering with the linear array. 8 antennas are there. So linear array number अभी आपने देखा था lambda by 2 से change किया तो we can shoot the beam. Next. Phase change. Then the small cell. Next. So, in 5G and 6G technology, what are the number of base stations are not sufficient. We have to not only increase the number of base stations, but also we have to deploy a small cells, which is on the tall buildings, which may be on the roadside, which may be on the lamp post. Not today. We are not using the 5G technology in India completely. We are still in the 2.3 or 2.5 generation, not exploring all. Okay, आपके मोबाइल फोन बड़ा क्या आता है 5G connection, but no. Okay, so if generally as we go on increasing the frequency, wavelength has to be decreased and they travel a lesser and lesser distance. It's very but natural because every signal has to travel a dozens of wavelength distance. Dozens of wavelength distance. अगर किलोमीटर में अगर आपकी मेगाहर्ट्ज में किलोमीटर में है, फिर corresponding wavelength it is in kilometer. If it is in megahertz, its wavelength it is in meter. If it is in gigahertz, its wavelength it is in millimeter or centimeter. Okay, so higher the frequency, there is a more attenuation, more obstruction. For example, if there is a tall building or there is a mountain, that you cannot propagate. Or if there is a tree, you cannot propagate. Means you can absorb because of the oxygen and the vapor, water vapor. These are the clouds. It can also attenuate the signal. है ना? वो जानते हो ground propagation, skyward propagation, tropospheric propagation वो छोड़ो. वो लेकिन बोलना ये है मुझे it cannot travel a long distance because of the multiple obstructions. Next, because they are in the millimeter. So what we have to do? We have to use the 5G antenna. So it's the inverse square law. So millimeter mm wave folded more while traveling through the building. That is folded more while traveling through buildings, walls, floors, trees, clouds. So they can make that. Distance will be getting smaller. Okay. So next. So we have to deploy such a type of numbers of say antennas so that these are number of base stations. Sorry. These are number of base stations we have to increase in the 5G communication. Not only that, but next we have to overcome the problem in the FM wave attenuation. Thousands of low power base station has to be utilized. These are the base station has to be utilized. That is for the small sector and next. So if user is here not getting the signal because of beyond the tree, okay, they will not get the signal. Next, then how to solve? Then we have to deploy the same antenna. Here the signal goes from base station to the same antenna and then goes in. Direct नहीं जा रहा है, indirect way. ठीक है? If you are here, you are not getting the signal because of the short tree. then it goes here, goes another base station, another cell antenna, small cell antenna, and goes. This is the way you have to get the signal by means of deploying the thousands of small cell antennas on the tall buildings, maybe on the lamp post and all. Next, see, they are to be deployed here on the lamp post, or it can be deployed in this way. Next, okay. So the पूरा structure कैसा दिखेगा? So these are all the red colors are the small cell antenna and the base. अभी ये इंडिया में घुसा है सब जगह, कितना खर्चा है? ठीक है, स्मॉल कंट्री है, जर्मनी वो हो जाएगा, ठीक है ना. यूएस में इंप्लीमेंट हुआ है बट नॉट इन ऑल द एरियाज. पर्टिकुलर मेट्रोपॉलिटन सिटीज जो उनके आइडेंटिफाई की है वहां पर रिसर्च टाइप ऑफ, बिकॉज ये इलेक्ट्रोमैग्नेटिक रेडिएशन होती है एंड देयर इज अ बिग रिसर्च इज गोइंग ऑन हाउ इट अफेक्ट्स ऑन आवर हेल्थ, कितना आप लोगों को अफेक्ट करता है विकसित यूजर. अभी कुछ लोग बोलते हैं यहाँ पे नहीं रखना चाहिए मोबाइल फोन, अपने से दूर रखो, कितने लोग फॉलो करते हैं दैट इज अनदर. ठीक है, सो कहने का मतलब है सच टाइप ऑफ थिंग्स टू बी यूज्ड. ठीक है, आगे. फॉर एग्जांपल, इफ यू आर इन अ स्टेडियम, thousands of people are sitting in the stadium, you are watching the cricket match, फुटबॉल मैच, कई लोग हैं वहां, हजारों दो लाखों लोग बैठे हैं. मोबाइल आता है ऐसे, फिर ऐसा नहीं लगता आपको यार मेरे को चीज आ रहा है, इसको भी आ रहा है, इसको भी आ रहा है, इसको भी आ रहा है. हाउ इज पॉसिबल? पहले पॉसिबल नहीं था. ठीक है, नेक्स्ट. सो in Mysore Memo, the spatial diversity is very important. Then the simplified resource allocation, then the spectral efficiency is and linear multi-user processing. Next. So this is the single user memo. You can get the signal from this, okay, to the one user. Then multi-user, you can get the user 1, user 2. Accordingly, you can get the thing. Next. For example, what is massive MIMO? I have told you. Now this is the 2T2R. इसको क्या बोलेंगे? 2T2R. 2 transmitter, 2 receiver. ये अलग है. So now this will get the things. अभी इससे let us say 75 Mbps signal is getting from one 1T1R, and 75 getting from another one. Okay. So let us say this becomes, we can say the total becomes 150 Mbps. यहाँ पे 44 आ 1 2 1 2 1 2 1 2 मींस हर इसमें दो दो है क्रॉस पोलराइज. व्हाई आई जस्ट शो दैट फिगर, व्हाई द एंटीनास टू बी प्लेस्ड इन द क्रॉस पोलराइजेशन. सो इन दैट सिचुएशन नाउ यू आर गेटिंग द स्पीड बिकम्स डबल ऑफ दिस. अगर यहाँ पे 150 है तो यहाँ पे 300 Mbps है. ठीक. सो then we can say 16 to 16R. If you just go with this, in that situation, now they are getting the things, speed will be further increased. If speed is not that much important, then we go next. They are the sub users. Each user gets the 4 times signal. So this is the way. So where it is used? 2T2R. It is used in the villages where the traffic is less. If you are in the city with the tall buildings, you can go with this. If you are in a stadium, you can go with this. Because यहाँ पे क्या है कि each individual should get the signal. आपके बगल में बैठा पर दो से बैठा, उसको भी कॉल आ रहा है, तुमको भी कॉल आ रहा है, both can speak very good. This is possible because यहाँ पे क्या हो रहा है, चैनल कैपेसिटी बढ़ गई, क्योंकि 4 यूजर को, यहाँ पे एक यूजर को 150 Mbps था, यहाँ पे एक यूजर को 300 Mbps है, यहाँ पे 300 Mbps इसको नहीं है, इसको नहीं, इसको नहीं, इसको नहीं. चारों यूजर को 300 Mbps सिग्नल मिल रहा है एट अ टाइम, एंड दैट इज चैनल कैपेसिटी विल इंक्रीज. नेक्स्ट. सो इसे बीम फॉर्मिंग बोले तो एक जैसा 2 है, इसका जैसा बताया मैंने आपको, इसकी बैंडविड्थ बीमविड्थ ज्यादा है. बीमविड्थ कैसे निकालते हैं? जो मैक्सिमम पीक है उसके 3D में ले जाएगा, जहां पे भी कट करेंगे 2 लाइन खींचेगी, जो एंगल है दैट इज कॉल्ड द बीमविड्थ. इन द सेंस बीमविड्थ अगर निकालना है मुझे, तो आई कैन से इफ दिस इज द बीम, आई हैव टू टेक 3 dB नेक्स्ट पॉइंट, ये 3 dB नेक्स्ट पॉइंट है, ओके, so I have to connect this, and this angle is called the beam width. बीम विड्थ और बैंडविड्थ में फर्क है, जो एंटीना में नहीं है उनको सिर्फ पता है ना, आप खुद नहीं करते हो। व्हाट इज द डिफरेंस बिटवीन द बीम विड्थ एंड बैंडविड्थ? ठीक है, बैंडविड्थ इज नॉट दैट इंपॉर्टेंट, बीम विड्थ इज वेरी इंपॉर्टेंट। Now, this is the way multiple beam जो देखेगा अपन ने, bigger array size, very directional beam will be formed. इसकी beam width तो बहुत कम है, gain बहुत ज्यादा है, इसका beam width ज्यादा है, gain कम। समझ में आया? चलो next. One more करो। Next. ठीक है, एक बैकग्राउंड। अब यहाँ पे देखिए, दिस इज द एंटीना से माइमोड हम यूज कर रहे हैं यहाँ पे, लो टीएक्स टीआर विथ 2T 2R, इन दैट केस वी गेट 1 2 3 4 5 6 बीम्स, ओके। बट जैसे ही हमारा बीम नैरो हो गया, वी कैन यूज 12 और 16 बीम्स हियर, मींस मोर नंबर ऑफ यूजर्स कैन गेट द सिग्नल फ्रॉम नेक्स्ट। सो दिस इज द वे these two users can get the signal. Next, so there is a possibility of interference. These are the three users getting signal from this as well as this. This is interference. किसी से भी नहीं मिल रहा है, सुनने कुछ भी नहीं आ रहा है, दो सिग्नल जंपिंग कर रहे हैं, ओके। बट अगर हम ये यूज करते हैं मीमो या माइमो बोल देंगे, तो हम क्या करेंगे, एक एंटीना इसको दे रहा है, दो एंटीना इसको दे देंगे, so there is absolute no cross connection. Perfect signal will reach to the particular person. Required signal to reach next, being formed with the gains. Now here is the CSI feedback. So let us take what exactly, this is the reference, okay, CSI reference I am, and this is the reference signal. They have to compare this, okay. So PMI, so these are the things, CSI get feedback, this is very important, and this goes into the 6G and 5G. So CSI feedback has the three parts. One is rank indicator RI, then channel quality indicator CQI, and then processing matrix information, that is PMI. But PMI के बाद information जो है, it comes from the CSI IM and CSI RS. Okay, these are the two things they compare, and now it goes to PMI. For example, this is the signal PMI 1 2 3 4, or this is the SNR 1 2 3 4. चार जगह से सिग्नल मिल रहे हो, अभी मैंने उसमें से कौन सा लेना चाहिए, विच सिग्नल आई शुड पिक फॉर द बेटर कनेक्टिविटी एंड द क्लियर कम्युनिकेशन। सो इसमें से जैसा कि ये है, चारों के चारों सिग्नल यहाँ पे मिले हैं, तो मैंने एसएनआर, लेट अस अज्यूम दैट एसएनआर 3 और एसएनआर 2 which have choose the better result, so I can choose that, and this is possible by means of that is the precoding matrix information. For example, next चलते हैं। So for example, यहाँ पे और यहाँ पे PMI सिग्नल मिला, यहाँ पे चल SNR 3 को चूज किया, SNR 3 को चूज करके ये हो गया, that is the channel quality indicator estimation हो गया, reduce the SNR to be converted to the CQI. CQI क्या होता है, channel quality indicator. तो यहाँ पे है, and you will get the better you can say SNR, so you can choose the PMI 3 and SNR 3 accordingly. Next. So for example, अभी यहाँ पे क्या है, if I going to read ना, it takes time. आई मैं तो 12 बज गए, चलो 12:30 तक की टाइम है ना, वेट कर लो, तो because we started little late. तो मेरा ऐसा है कि जितना समय शुड बी, आई शुड डू 100% जितना मेरे बनता है, ठीक है। होने के बाद कुछ प्लस मिला, इतना ही अपेक्षा है, बहुत कुछ तो समझ में नहीं आएगा, ओके। लेकिन एंटीना जो लोगों के लिए नया है उनको कुछ तो सब ऐड होगा, और जो एंटीना में एक्सपर्ट भी होंगे वो भी बोलेंगे नहीं नहीं समथिंग गुड, वी विल, आई थिंक यू आर फ्रॉम द एंटीना लिटिल बिट, सो you are also getting the better information what you have here, okay। Let us assume because these are the cases of multiple presentations. I will put it as per the to get the something new, है ना? So let us say this is called the horizontal beam, this is called the vertical beam. ठीक है? यानी horizontal के लिए मैं क्या बोलते हैं I11 and vertical के लिए बोलते हैं I12. So the UE needs to tell the 5G cell about the base beam that can be possible with the help of PMI feedback. Then this can be done by using the CSI feedback. CSI feedback carries PMI information which has two important components I11 and I12. I11 for horizontal, I12 for vertical. This is for horizontal and this is for vertical. So the I11 is tells about the beams in the azimuth direction. Azimuth means horizontal direction, and I12 is used to tell about the vertical direction, so the elevation plane and azimuth plane. You might have idea about the elevation plane and azimuth plane. क्या होता है elevation azimuth? अगर vertical है, for example, this is the radiation pattern. These are the side lobes. This is the backbone. So this information is azimuth, and this information is elevation. ठीक? So अभी यहाँ पे देखिए आप. If you see this user 1, it is shown in the green blue color. This is orange color, and this is user 3. Okay? This is horizontal I11. This is vertical I12. Okay? So let us say this particular blue will get a signal from beam number 2. Let us say orange will get the beam number 4, and green gets the beam number. Let us take 10 or 10. Let us have it. Okay? So CSR feedback indicating beam, and this is the CSR feedback indicating beam 2, and this is for the beam 10. This is 10 and this is for 2. So let us say this is I11 5. अगर ये I11 का horizontal axis यहाँ से 0 1 2 3 4 5 I11 5, okay, and I12 क्या है 0. So it becomes I12 is 0. So I can get this location. The user is here. So I can get this type of feedback we are getting from PMI, and PMI will do this. For example, if you are moving from this distance to this distance, अभी यहाँ पे I11 तो वही है 5, same, there is no change. Then I12 जो है it should be a 6. So you can look at the things. So accordingly, we have to focus the particular beam to the particular user, so that CSI information gives up information to the mobile phone and tower, and then you can choose the correct. Next. For example, vehicle is here. If the vehicle is here, जैसे कि ये कार यहाँ पे पहले यहाँ थी, जैसे I do that. I11 is equal to that is I11 is horizontal is equal to 11, vertical is equal to 0. तो बीम यहाँ फोकस हो गया था. ये vehicle यहाँ से निकल के यहाँ पे गया. तो beam has to be focused here. Okay. Next. So see the beam to be focused here. अभी क्या है? I11 जो था अभी 2 हो गया, जो 6 था पहले वो अभी 2 हो गया. क्या था 11 था अभी वो 2 हो गया, और I12 still it is 0. Then find out the location and then beam to be focused. That is the things that antenna base station has to do. Next. For example, अभी कार इधर पलट गई, 90 डिग्री टर्न था रोड का, इधर यहाँ पहुँच गई. यहाँ पहुँचने के लिए क्या हो गया? अभी ये तो वही था. अभी I11 क्या था? Horizontal, it is 3 close to this, and I12 क्या हो गया? जो 0 था वो हो गया 4. The beam will be focused in that time. Next. So it not only focuses the thing. If it is the tall building, then person will be on the ground floor. They can get the signal. I11 is equal to let us say 15, and I12 means vertical is to be 0. Next. अगर यहाँ चला गया last floor पे, ठीक? So beam has to focus. Next. So the multi-user MIMO, what is exactly? They are forming the multiple beams. अभी यहाँ पे क्या है? This is called a multi-user, but it is in the frequency domain. Okay. So now this green color will get the 50%, blue color will get 30%, orange will get 20%. These are the way that time slot is common, but frequency spectrum is to be allotted accordingly. It is that. And here is the single user. For the single user, it is okay. But for multiple users, next, we have to use this step. What we did here, यहाँ पे हमने क्या किया? ये जो दो थे, सबका सम कितना आ गया 100। ये जो दो थे उसको मैंने क्लब कर दिया। क्यों किया? क्योंकि दो जो बीम थे ऑरेंज छोड़ के ब्लू और ग्रीन वो दो एक दूसरे से दूर है, तो allocated the same spectrum, so इसकी efficiency बढ़ गई। जो हमारे 30-50% थी उसकी भी 80% बन गई, जिसकी 30% efficiency थी उसकी भी 80%। फिर आपके पास में सवाल आएगा कि why should not orange to be merged? ऑरेंज को क्यों नहीं किया मर्ज? सो रीजन है कि दे आर वेरी क्लोज टू ईच अदर and there is a possibility of cross connection, so I avoid this। लेकिन अगर मैंने इसको मैसिव MIMO में कन्वर्ट कर दिया तो ये जो दो बीम है, ये 2 नंबर का बीम हो जाएगा 2 रहेगा, तो ये 4 नंबर का बीम जो होगा वो 40 हो जाएगा। ये अगर 20 हो गया 2 नंबर का तो ये हो जाएगा 40 नंबर। अभी दोनों में काफी डिफरेंस है, दो बीम के अंदर में 20 बीम का फर्क है, तो उसको भी हम मर्ज कर सकते हैं। मींस कहने का मतलब ये है कि इतना नैरो और फोकस बीम फॉर्म हो जाएंगे वो कि देयर इज अ लेस पॉसिबिलिटी ऑफ मिसिंग, सो आई कैन ऐड दिस। तो यहाँ पे अगर आपकी एफिशिएंसी 80% तो नहीं होगी, 80 मींस 80 फॉर यूजर नंबर ब्लू एंड 80 फॉर यूजर नंबर सी मींस 160 ये हो गया, और ये 20 इसका टोटल कैपेसिटी हो गया 180 एमबीपीएस। कैसे? तो इसको भी 60 मिल रहा है और ब्लू वाले को भी 80 मिल रहा है। 80 प्लस 80 60, सॉरी 160 प्लस 20 मींस वो टोटल कैपेसिटी कितनी होगी 120 एमबीपीएस की होगी। अगर मैंने इसको मैसिव माइनो में, ये तो हो गया आपका सिंपल माइनो, अगर मैसिव में कन्वर्ट कर दिया, ये तीनों को ऐड कर देंगे तो फिर इसकी एफिशिएंसी और भी बढ़ जाएगी। यानी ये क्या हो जाएगा, तीनों को जब क्लब करेंगे सब तो 100% रहेगा, लेकिन तीनों को साथ में ऐड करोगे तो इसका 100%, इसका 100%, इसका 100%, इस टोटल इज 300%। मीटिंग कुछ समझ में आ रहा है कि नहीं आ रहा? कि तो ऊपर से जा रहा है, चांसेस है ऊपर जाने की, क्योंकि आपका अगर टॉपिक है देन यू दे दीजिए। दैट्स व्हाई आई स्टार्टेड विद द बेसिक्स एंड देन वी गो टू द देन वी विल नेक्स्ट सी these are the way। Okay, so that is called the elevation beam forming, this is called the azimuth beam forming। जो ground पे उसको azimuth बोलते हैं। ये next see the particular result, CSI period azimuth and elevated beam forming, norm process that CSI RS reference signal है top versus beam forming CSI RS bottom, these are beam forming things with this। Okay, downlink, base station and user। next वही है। ओके नेक्स्ट, सो ये डायसो वालों का एडवांटेज हमने शुरू में देख लिए थे, देयर इज नो नीड टू रिपीट अगेन। नेक्स्ट, so these are the massive MIMO progress, that is the power versus path loss, fixed link, this is mobile user, time versus Doppler, that is 2G, then the wideband frequency delay 3G, and this MIMO spatial and angular, that is the colorimetric 4G, and now this is the 5G and 6G further, that is wide frequency range, non-stationary arm। Next, so these are the way, this is the beam forming for dual user, these are the way। Okay, generalized beam forming, this is called, that is the single user MIMO। एक यूजर को मल्टीपल सिग्नल मिल रहे हैं, they have to take a decision which to be a base, and now this is the मल्टी यूजर, 1 2 3 4 यूजर को एक साथ। चल नेक्स्ट, चल छोड़ पढ़ लेना। नेक्स्ट, चल छोड़, नेक्स्ट इसको भी ड्रॉप करो, चल इसको भी छोड़ दो। ठीक है, these are the way, these are the cell antenna, is to be focused like this। Okay, this is the high precision spectral efficiency। high precision means pinpointed ही जाएगा, that's why even if you see thing in the stadium with a lakhs of people, you can listen because of very sharp beam distance। And next, चलो इसको भी छोड़ दो। ये है टोटल, यहाँ से देखिए सिग्नल कहाँ जा रहा है, टॉल मीटिंग्स में as well as downward means horizontal azimuth as well as vertical elevation. Next. These are the way it continuously tracking the person as it moves from one place to another place. It will get the signal continuously without breaking contact. Next. So this is called the antenna polarization, and this is the antenna 1 and 2. This is blue color. If you see behind, and this is the red. This is 2T2R. This is also 2T2R. है ना? तो ये दो लेयर है इसमें. ये है टोटल 1 2 3 4 5 6 7 8 8 by 8 plus 8 by 8 64 by 6. Such a type of arrangement we are using here. Next. See, this is the panel. I have taken this from this particular YouTube channel. Okay, the phase array that to be focused in a particular. These are the panels to be used. Okay, next. For example, जैसे कि panel है. Let us take the conventional array. This generalized sub array 8 elements है यहाँ पे. If you just count 1 2 3 4 5 6 7 8. 8 elements grouped together. It will form a bit. ठीक है, लेकिन यही ऑप्शन है क्या? इन द FD MIMO array, ओके, सब array is equal to k is equal to 2. सो मैं दोनों को ही क्रॉप कर सकता हूँ. ये दो array कहीं तो भी फोकस करेंगे, ये दो array और भी फोकस करेंगे, ये कहीं और करेंगे, ये कहीं और करेंगे. You can get the multiplier. If it is a massive MIMO, individual control over antenna element. Individual antenna can also focus with the help of massive MIMO, and that is the beauty. Okay, यहाँ पे एक सिंगल 8 या फिर 2 या फिर 4 या फिर 8 ठीक है नहीं होता है. ठीक. Next. So let us say this is a 70 centimeter. This is 170 centimeter. ये अगर कलर का लेना है, क्या 1.8 gigahertz massive MIMO. ठीक. 64T 64R वो जो पहले बताया था पहले. 64 ट्रांसमीटर 64 रिसीवर अगर है तो ये साइज है. अगर 2.6 पे गया तो साइज हो गया 50 by 100. मींस ये कितना है 140 मीटर 100 सेंटीमीटर कितना है मीटर में. तो जस्ट कैलकुलेट इट इज 1.4 मीटर by say 0.0 मीटर. चलो ठीक. 7 सेंटीमीटर में याद रखो. ठीक है. दिस इज 50 by 100. अगर आपने और बढ़ा दिया it becomes 40 by we can say 90 cm. If it is 6 gigahertz और imagine करो अभी 20 gigahertz 70 gigahertz 120 gigahertz तो क्या साइज होगा. तो यहाँ पे देखो उतने ही एलिमेंट है 64R 64T यहाँ पे ये साइज में लगे हैं. अगर मैंने फ्रीक्वेंसी बढ़ा दी तो साइज घट गया लेकिन नंबर ऑफ एलिमेंट उतनी है. मैं इसको यही साइज करके बढ़ा दी. I can increase the more number of elements. Okay. Now heater size will be further decrease. ये सेल साइज की बात कर रहा हूँ, आपकी मोबाइल फोन की बात नहीं कर रहा. ओके. तो नेक्स्ट चल छोड़ो. देखिए अभी ये सिंगल यूजर है. अभी सिंगल यूजर में 4 पैनल है. ये 1 2 3 4. मैंने एक पैनल दिखाया था 64T 64R वाले, ऐसे 4 लगा दिए मैंने. तो चारों से सिग्नल एक ही यूजर पे आ रहा है. Now with the help of CSI feedback, he has to find out which to be a base. ठीक. So, but in multi-user, हर एक अलग-अलग फोकस करता है. एक पैनल एक, लेकिन एक पैनल 100 को भी कर सकता है. ये एक पैनल 100 को भी कर सकता है. ये पैनल जस्ट इमेजिन. डिपेंड करेगा how many elements in this पैनल. नेक्स्ट. ये अगर मोबाइल फोन है, आपके मोबाइल फोन में भी ये मल्टीपल RF मॉडल है. If I ask the question, how many antennas in your mobile? Just I think 5 to 6. ठीक है. एक तो तुम्हारा ब्लूटूथ हो गया. चलो कौन से मुझे एक हो गया ब्लूटूथ, एक हो गया वाईफाई, एक हो गया तुम्हारा 800 के लिए, एक हो गया तुम्हारा 900 मेगाहर्ट्ज के लिए. ठीक. और कुछ उसमें से सिर्फ रिसीविंग वाले हैं, कुछ सिर्फ ट्रांसमिटिंग. ठीक. So such type of things you can get here. So enough support antenna switching. Okay, next. So these are the way the antenna for the 4th generation base station. इस तरीके से था. It radiate the power in all the direction this way, downward only, not in the vertical direction. But in the 5G or 6G, it focuses a particular user. Okay, not only in the ground but in the elevated also. Next. So these are the size 32P, 32R, massive MIMO. अगर आप देखोगे इस तरह से आपको दिखेंगे एंटीना डिफॉल्ट बिल्डिंग के ऊपर। फिर 64P 64R 2.5 गीगाहर्ट्ज बहुत बढ़िया, और 64P 64R ये हो गया आपका और मैसिव MIMO. So these are things it's called sector antenna. Next. So these are placed in the problem. Okay, easy installation, fast deployment. अब यहाँ से एक जा रहा है, वो होता है यहाँ से सीधा ले लेगा, यहाँ से आएगा, फिर यहाँ से आएगा. चलो next. So these are the main massive one. It looks like this base station actually. Okay, next. Applications used in this area, mission, that is the critical communication. वहाँ पे सब कुछ काम आता है. Next. Applied use of that is the connected and the self-driving vehicle. Next. देखो यहाँ का भी ये अपना इंडिया में तो होने का है, लेकिन टेस्ला ने वहाँ पे किया है लॉन्च. टेस्ला इंडिया में भी आया है, लेकिन इंडिया में भी दो हर एक 10-50-100 एक्सीडेंट होते रहेंगे, है ना. वहाँ पे ट्रैफिक भी कम रहती है, लोग भी डिसिप्लिन है. मैंने एक अवसर क्या मैंने वीडियो किया था, तो वहाँ पे बड़े डिसिप्लिन से सब आते थे. जैसे नागपुर में आने के बाद दौड़ रहे लोग एयरपोर्ट, और एयरपोर्ट को आपको दौड़ना पड़ता है, ये भाग रहे लिटरली भाग रहे, और वहाँ पे क्राउड करेंगे. वहाँ एकदम डिसिप्लिन वेल किसे डिफाइन है, वहाँ पे कोई हिम्मत नहीं करता. यहाँ पे चालू हो गए, तो ये आपका माइंडसेट का डिफरेंस है. तो यहाँ पे ये वाले टाइम लेवल है, ये व्हीकल टू व्हीकल कम्युनिकेशन, ये पूरे एंटीना यहाँ लगे लैंप पोस्ट पे, and accordingly they will get disturbed. Some it is in the side road side also that is place, they can communicate with each other. Next. Then industrial automation के लिए काफी काम का है ये, बहुत सारा काम. नेक्स्ट ये पढ़ लेना आपने, बहुत सारा ये है. the healthcare applications of doctors in US operate patient in India very easily. Okay, next. Then drones and unmanned aerial vehicles के लिए भी काम में है. Next. And now this is the area you just, if someone is interested, cellular radio web safety, 5G, 3G and 4G and 5G. भाई इसका अपने शरीर पे कितना हार्म होता है, this still is going on, है ना. लोग बोलते सर के पास सोचे हुए नहीं रखना चाहिए. अरे क्या पता ये कंसेप्ट है, कुछ एडवांटेजेस कुछ डिसएडवांटेजेस, है ना. नेक्स्ट. So I tried to give some additional information what you have earlier. That is the only purpose of this lecture, because I cannot teach you the whole idea in the 2 hour span. But how it works, what are the basics, how the current flow, how it radiates. It's a mechanical device, na? It is a transistor mechanical. Electrical we are signal converted into electromechanical. Nothing but वो क्या है, metal pipes. So that is it. If you have any questions, you can ask. I will open to all.
Now please. Perfect. Sir, in satellite phone, when our Indian Army use that satellite phones, so what kind of antenna they use?
You are also using satellite. तो ये क्या सिग्नल वहाँ से नहीं आता क्या? वाईफाई पर नहीं आता. Satellite phone means the particular frequency range they use, which you cannot. But it doesn't mean you are not using the satellite phone. You are getting the signal from satellite. लेकिन उसको satellite phone इसलिए बोला था कि particular frequency is allocated to that military purpose. No other can use it, and that is the difference. Antennas might be the same, है ना? Same ही रहेंगे, क्या रहेंगे अलग? There might be some changes, but they are allotted with some different frequency, which you don't have access.
Sir, if we have to make the experiment of this beam forming,
Beam forming, it is in software. There is a lot many softwares are available. That is simulation. Simulation. हार्डवेयर में बीम फॉर्मेट करना अपने लिए सिर्फ एंटीना बना के काम नहीं होगा, उसके लिए फिर अपने को डीएसपी प्रोसेसर भी लगेगा, कुछ माइक्रोकंट्रोलर भी लगेंगे,
फोकस भी कंजम्पशन भी बढ़ाना पड़ेगा। मैं बोला ना इतना अकेला एंटीना स्मार्ट नहीं है। स्मार्ट एंटीना या फिर मैक्सिमम एंटीना ये स्मार्ट तब बनता है जब उसके साथ में और भी चीजें जुड़ती हैं। ठीक, तो वो स्मार्ट एंटीना अगर आपने टॉपिक लिया पीएचडी का डिजाइन एंड इम्प्लीमेंटेशन ऑफ स्मार्ट एंटीना पढ़ेंगे, अगर लिया भी होगा फिर आपको कुछ कभी उसको नया नाम देना पड़ेगा, क्योंकि आपके लिए फिर वो सब कुछ सिस्टम बनाना पड़ेगा। उसके बदले में डिजाइन एंड मल्टीप्लिकेशन ऑफ एंटीना फॉर द वायरलेस कम्युनिकेशन ये बोलना इजी है और करना भी है।
जो वायरलेस पावर ट्रांसमिशन बीम फॉर्मिंग का यूज
जो आपको वायरलेस मोबाइल क्या है वायरलेस में
नहीं पावर ट्रांसमिशन वायरलेस पावर ट्रांसमिशन
हाँ अच्छा वो आपकी बात है। हाँ
हाँ तो उसमें पावर जो है वो बीम के थ्रू पावर कैप्चर करना ये जो होता है फॉर दैट दे यूज सर्विसेज frequency selective services. So if you have to practically see this at a very I would say small level, simple experiment can be do it.
नहीं यू कैन डू इट बट यू रिक्वायर लॉट ऑफ थिंग्स। सबसे पहले जैसे हमारे यहाँ पे वाईसीसी में आई हैव परचेज सीएनसी मशीन विथ व्हिच वी कैन फैब्रिकेट, लेकिन वी हैव ओनली एफआर मटेरियल की बात, सिर्फ मटेरियल की बात, उसमें कई सारे मटेरियल है। एक आरटी ड्राइव है जिसकी कॉस्ट एफआर से 10 टाइम्स ज़्यादा है। ठीक, फिर अगर आप उसमें और वाटर मिलेगा और उसकी तो कहने का मतलब है रिस्ट्रिक्शन। फिर उसको समझने के लिए आपको लगता है वेक्टर रेट में आ रहा है वो नहीं मिलेगी। हाँ इफ यू आर फ्रॉम द सम गवर्नमेंट आईआईटीज में है तो यू विल गेट सम फैसिलिटी इन दैट। तो ये कॉलेज में या आईसीसी में फिर उसको लगता है एनापाइक चेंबर जिसकी कॉस्ट करोड़ों में होती है, तो होगा कब है ना। अभी वो आईआईटी दिल्ली के साथ कौन सी कंपनी है वो उन्होंने वो बना दिया माइक्रोस्ट्रिप एंटीना, माइक्रोस्ट्रिप कंपोनेंट पावर डिवाइडर डायरेक्शनल कपलर विद द हेल्प ऑफ स्ट्रिप लाइन, सॉरी मींस माइक्रोस्ट्रिप लाइन। ये मालूम होगा ना आपको माइक्रोस्ट्रिप लाइन विच वी कैन ट्रांसमिट द सिग्नल, माइक्रोस्ट्रिप लाइन, स्ट्रिप लाइन, शिल्डेड लाइन, दैट इज द वे डिफरेंट टाइप्स ऑफ लाइंस आर देयर। सो हम उसको बना सकते हैं, हम उसको उसको भी परफॉर्म करना इट इज नॉट अ सिंपल टास्क योर इट इज really level, because we have to see only the frequency versus output. We have to vary the frequency from C band लेवल हम यूज करते हैं, इसका 2 से लेके 1 से लेके तो हम 5 गीगाहर्ट्ज तक जाते हैं, या फिर 2 मेगाहर्ट्ज से 5 गीगाहर्ट्ज, and we can see the only the low pass filter, high pass filter, band pass filter, ये भी चीजें हम implement कर सकते हैं with the help of planar microstrip line। वही परफॉर्मेंस है, इसके अलावा कोई अदरवाइज यू हैव टू डू योर इंटर्नशिप और यू हैव टू गो टू द एज अ वी कैन से क्या उनके साइंटिस्ट को असिस्टेंट लगते हैं, दे आर गिविंग 67,000 ओके। लेकिन मैं तो मतलब जाना चाहिए नए लोगों ने, आप में से कोई नया तो नहीं दिख रहा, बहुत कम लोग हैं नए में, जाना चाहिए 2 साल बाद रह लो, बहुत कुछ नॉलेज गेन करो एंड देन यू आर अनस्टॉपेबल। क्या है पढ़ाना और बताना, वेरी सिंपल। अभी मैं उसको इमेजिन करता हूँ क्योंकि मैं उसमें पढ़ रहा हूँ, आपको तो इमेजिनेशन भी करना टाइम जाए कि व्हाट एग्जैक्टली गोइंग ऑन। जैसा मैंने सीएसएल लिखा हुआ है एक्चुअली वो बेसिक हार्ड है माइनों का, वो बताने जाऊंगा ना शुरू से तो पगले हो जाओगे आप, क्योंकि समझ में आएगा नहीं, है ना। तो उसको मैंने सबसे आखिरी में शॉर्ट में बताया कि भैया कहाँ से कैसे मूव होते हो, वैसे वैसे उसकी पोजीशन वो आइडेंटिफाई करता एंड अकॉर्डिंगली बीम हैज टू बी फोकस कंटिन्यूअसली ट्रैक यू। मैं तो बस सीजी में आरएस है, 7 में और कुछ होगी, एफआरएस में जो भी होगी, है ना। वही है ना, जैसे जैसे ईयर पास हो जाए, मैं क्या बोला 10 साल से पहले सोचा था कि ऐसा होगा कि यू कैन डाउनलोड एचडी वीडियो इन फ्यू सेकंड, सोचा था क्या? नहीं सोचा था, आज पॉसिबल है। अभी जो अपन अभी तक अनपढ़ है, अपने दिमाग में कुछ है ही नहीं, 10 साल के बाद वो भी हो जाएगा। कहने का मतलब ये है कि एवरी डे technology is changing, someone remove something, add something new, वो तो होने वाला है, it should be continued and you cannot keep all the things to be tracked, है ना। इवन तू भी मुझे पूछेगा कि सर 5 साल के बाद क्या होने वाला है, हाउ प्रेडिक्ट, नॉट पॉसिबल ना। वही बोला ना, हम बैंक पे जाते कि आज जनधन नहीं गया, क्यों पॉसिबल हुआ? हाई टेक्नोलॉजी, 4G टेक्नोलॉजी, है ना। तो डिजिटलाइजेशन हुआ है ना, क्या हुआ? वही है ना। अभी कम्युनिकेशन की बात कर रहे हैं अपन, क्योंकि एंटेना के बारे में, लेकिन इन जनरल भी बता रहा हूँ। इसलिए मैंने स्टार्ट किया था 5G टेक्नोलॉजी। टेक्नोलॉजी की क्या रिक्वायरमेंट है एंड हाउ द टेक्नोलॉजी रिक्वायरमेंट फुलफिल बाय द एंटीना, क्योंकि आपका उनका टाइटल भी बड़ा खतरनाक है, फ्यूचरिस्टिक एंटीना एंड ऑल। तो मैंने बेसिक से स्टार्ट किया, फ्यूचरिस्टिक क्या होगा और क्या है ना।
Sir,
हाँ,
how to select the material? As you said, it is.
you don't have any option. You don't have any option. You have to select only a function. If you are doing simulation, you decide the lower dielectric. जैसे FR4 का डायरेक्ट्रिक कॉस्ट होता है 4.1 से लेकर 4.3 एक्सप्लान आर डायरेक्ट्रिक कॉस्ट। जितना कम लोगे उतनी कॉस्ट बढ़ेगी। आरटी ड्यूराइड का होता है 2.1 से लेकर 2.3 डायरेक्ट्रिक कॉस्ट। तो उसका शीट ही मंगाना एक प्राइवेट कॉलेज के लिए नहीं के बराबर।
What parameters will change with the change in the material? This what will
एवरी पैरामीटर,
betterment in which parameter?
लोअर डायरेक्ट्रिक कॉस्ट। हाँ, आप एक पेपर आप देख सकते हैं कि बाबा FR4 से किए हुए रिजल्ट क्या आते हैं और बाकी सब कुछ सेम विद आरटी ड्यूराइड से क्या फर्क पड़ता है। Their efficiency will increase, their losses will decrease, means gain will increase, all the parameters get enhanced, है ना। फिर सबसे lowest dielectric constant, अच्छा tell me the material whose dielectric constant is less than 1. Anyone? You can Google it. Google. Material whose dielectric constant less than 1. मोबाइल होंगे ना, यूज इट करो। डायरेक्ट्रिक कांस्टेंट लेस देन 1। जो भी मटेरियल का नाम बताएंगा उसको मैं मेरी तरफ से एक गिफ्ट दूंगा। एक्सपेंसिव रहेगा, जो मेरे पास तो नहीं है ना, मुझे लाने की जरूरत पड़ेगी, क्योंकि आप दोगे ही नहीं आंसर। कोई ऐसा कोई मटेरियल है ही नहीं। मेरे को देने में क्या लगता है, एक्सपेंसिव गिफ्ट दे दूंगा। लाओ मटेरियल ढूंढ के, whose dielectric constant less, but we can make it the dielectric constant less than 1, and that is called the engineering material, which can be fabricated by some technique, and name of that material is meta material, whose dielectric constant is less than 1. Lekin if you go to the market and ask for the meta material in the universe, no one can provide you. Because it is not readily available. It is not available. It has to fabricate. How to fabricate these things? I will explain and then I will stop. So basically,
But epsilon non-zero material is also.
huh?
Epsilon near zero.
Near zero is air. 0.03 air and अभी एयर में तुम मुझे बता दो चीजें प्लेट पे रखना है। एयर में कैसा रखेगा? बीच में हवा है, तो यू हैव टू यूज फोम। फोम का है, उसका डायरेक्टली कॉस्ट होता है 0.07, दैट यू कैन यूज। लेकिन वो सपोर्ट कितने देर देगा, है ना। तो फोम है, एयर भी है, लेकिन मेरा क्वेश्चन था कि लेस देन 1 किसका, लेस देन 0 ऐसा कोई मटेरियल है ही नहीं। गूगल करो ना, यू आर गूगल वालों को कुछ डिफरेंट रहते ना, करो गूगल, बताओ। ये ओपन चैलेंज है, नहीं कर सकते, कोई मटेरियल है ही नहीं ऐसा। हाँ, इसको बना सकते हैं बाय मींस ऑफ डूइंग सम एक्स्ट्रा इंजीनियरिंग एक्सरसाइज, आर्ट वर्क ऑन द ग्राउंड पे, एंड दैट इज नथिंग बट इफ यू आर एंटीना, दिस इज एंटीना यू हैव। अब इसके ग्राउंड प्लेन में क्या करो, ऐसे आप रिपीटेटिव स्ट्रक्चर डालो, रिपीटेटिव स्ट्रक्चर का ऐड करो, कोई भी Not this is circle and concentric circle. Any structure you can add, but it should be repetitive with certain distance. Distance निकालना not that much. So always use lambda by 2. तो जो मटेरियल बनेगा उस डायरेक्ट्रिक कांस्टेंट को देगा, and the name of this material is beta material. वो पूरा टॉपिक क्या अलग है, बोला ना एंटीना इज अ ओशन, ये समुद्र है, उसमें से अपन ने एक बूंद पानी निकाला बस, पूरा समुद्र है, हमने उसमें से एक लोटा भर पानी निकाला, बाकी कुछ नहीं, वो सूखने वाला था ही नहीं, एक एक लोटा कितना निकालोगे, तो इससे ह्यूज एरिया, एक एरिया लिक्विड एंटीना, लेटेस्ट डायरेक्ट्रिक इज ए लिक्विड, बहुत सारा रिसर्च चालू है एंटीना, आप लिक्विड एंटीना सर्च करोगे आपको मिल जाएगा गूगल, different dielectric or different liquids to be used as a dielectric, and people are working on it. They are very important for the undersea communication. 70% अपना पानी है, इस कई सारे समुद्र आएंगे, अभी यूएस में जाते से कम 2-4 तो समुद्र आती होंगे, तो मैंने जब बैठा था तो मुझे मैक्सिमम समय तो मैं समुद्र पे था, 18 घंटे की फ्लाइट थी, पूरा नहीं आता, अभी तो 16 घंटे पता है, 18 घंटे की नॉन स्टॉप फ्लाइट, आधे से ज्यादा समय तो मुझे समुद्र ही दिखा, तब समझ में आया कि हाँ यार जमीन पे 70% पानी है, पक्का है, तब तक सिर्फ सुनने में आया था, पढ़ने में आया था कि 70% वाटर ऑन द अर्थ और 70% पानी है, और तब रियलाइज किया जब देखो क्या स्क्रीन पे आपके सामने एक स्क्रीन होती है, आपने गए लोग सामने से स्क्रीन है, ये समुद्र हो गया, ये दूसरा समुद्र आ गया, फिर एक समुद्र आ गया, अरे मुझे कहीं गिरा तो समुद्र में गिरने वाला अपन जमीन पर गिरने वाला, तो तब मैं रियलाइज हुआ कि हाँ भाई हाँ बराबर है, जमीन पे 70% पानी है, तो उसके अक्रॉस में कम्युनिकेशन करना, वहां तो कोई तुम ये नहीं कर सकते, एंटीना तो नहीं लगा सकते, कहाँ देखा देखा तो ऐसा ही समुद्र में एंटीना लगा हुआ होगे भी नहीं भी पड़ता कुछ होगे भी, लेकिन कितने इंस्टॉल कर पाओगे, कितनी जगह स्ट्रक्चर करोगे, थाउजेंड्स ऑफ किलोमीटर डाउन, कहाँ से लाओगे उसका बेस, इमेजिन तो करो, तो उस केस में अंडर वाटर एंटीना इज आल्सो, कल तुम्हारे आएंगे 2 दिन के बाद, वन ऑफ द एक्सपर्ट अनिल कुलकर्णी, he has excellent knowledge, वो मेरे से भी तुमको 10 गुना अच्छा बताएगा, because he is also actually working in the undersea entities, और अच्छे से बताएगा कि what exactly is going to सूखना, सब बोलना आप अंडरसी करते हो ना, क्या सब मतलब एक्सप्लोर करिए वाटर एंटीना अंडर और अंडर बताएंगे सर, अभी कुछ ने किया है, तो he might be have good knowledge because he is working in that area only, मैंने इसको पूछा कि वो उसका टीचर तो मैं भी आपको बताऊंगा, क्योंकि कुछ सीखने के लिए मिलता है तो अच्छी बात है ना, जरूरी नहीं कि you might have more better knowledge than me for some particular area, I might have good knowledge for the some particular area, no one is expert in all, कोई नहीं एक्सपर्ट, कौन है, I am not saying I am the expert of it, no, अरे क्या है कि ना हमारा समुद्र है भैया, उसमें कुछ भी पूछ सके सब कुछ पता है, तो देखते हैं how it is possible, ठीक, so any other question? Okay, so we hope you are getting some additional information with that expectation.